Hello everyone, how are you guys? I hope you guys are doing extremely well. Sorry for being inconsistent because as I had decided to share some valuable information with you, and to share those things I need to read and study a lot, so it takes a lot of time. I know this is just an excuse, but still I am trying to be more consistent. And yeah, so today is day 14 of my hashtag 30 days of talking to camera challenge. I know I have skipped some day and missed some days due to various reasons, so I'm not going to talk about that. So let's, without wasting any much time, let's jump back to our topic. So in the previous videos I have talked about searching algorithms, sorting algorithms, and some problems based on the searching and sorting algorithms. So what is the topic for today? So today I'll be talking about linked lists. So let's start. First, it is important to know what is linked list and why do we need to use it. Suppose, let me give you an example. Suppose you are given an array of integers like 1, 2, 3, 4 and 6, and now suppose you have to add 5 and 8 in it. So what we can do is, if you have to insert two new elements, then in that case you will create a new array of the size which is like the size of previous array was 4, so you will create a new array of size 4 plus 2, which is 6, and then you can insert all these elements in that array. And for that you are taking extra space, and you have to traverse a lot. Suppose you have to insert any element in the middle of the array or at the last of the array, so in that case you need to traverse the whole array, and then you can insert or delete any element. So this is taking very much space. The copy operation is inefficient. To remove this inefficiency, in addition of new data, linked list is used. So I hope it is clear why we use linked list. So let's now talk about linked list. So what is the linked list? So basically the linked list is a list of items, and these items are called nodes. Nodes are basically blocks. So what these nodes have? These nodes have basically two parts. One part is value part and one part is the address part. So what it does is, so suppose this is a node and it has two parts. So one is value and the next is address. So the first value part would have some element, and the address part would point to the address of the next node, and similarly like that. It is, you can imagine it like a train. The coach of a train has all the elements, and there is a connector which contains the through which we can go to the another train. And now the value of the value part of the node can be a basic data type, like it can be an integer or it can be any other data type. It can be any other data structure like strings or integers or float or double, etc. It can be anything, but we have to make sure that the data types in all the linked list should be same. So we can't do like this, that we can give the integer in first node and the string in second node. So this is not possible. So the link part is a pointer which is used to store address of the next element in the list. So now let's talk about some parts of the linked list. There are various parts of the linked list. First one is head. So what the head is? Head is like the engine of the train. The engine of the train likewise is the head of the linked list. So through head is the pointer which holds all the linked list. So head is the pointer that holds the address of the first node in the linked list, and likewise we can go to till any node which we want. What are nodes? Nodes are like the coaches in the train. Similarly the nodes are for linked list. So third, value. What is value? Like the passenger are in coaches of the train. In the similar way, values are for nodes. Nodes are coaches and values are the passengers for the linked list. The values are the main element which we store in the linked list. And next, what is link? Link part of the node is used to store the reference of another node. We usually use next or previous to store address of next or previous node. This is a basic nomenclature. Now let's talk about some different types of linked list. What are different types of linked list? Throughout this video, or like maybe in the 2-3 videos further, I'll be talking about some different types of linked list and some basic problems based on linked list. I won't be covering some difficult problems, because if I am trying to explain difficult problems, then in that case I need to have a whiteboard or a blackboard, or I have to show you the code and everything. So I will just try to make you visualize the things and make things clear to you. So what are some different types of linked list? Some different types of linked list are single linked list, doubly linked list, circular linked list, and the last one is doubly circular linked list. So now let's talk about each linked list one by one. First, let's talk about single linked list. So what is basically a single linked list? See, first of all, you may have a question in your mind that all these are linked lists. So what is the like main difference? Like what is the thing that is differentiating one type of linked list, like single linked list from doubly linked list, or circular linked list from doubly circular linked list? So the main difference among all these linked lists are how their nodes are connected to each other. Now let's talk about our first type of linked list, which is single linked list. So what is single linked list? In single linked list, each node has a reference to the next node in the linked list, and the link portion of the node contains the address of the next node. So in that way, but the link portion of the last node contains the value null. So basically the last node is not connected to any other node. The last node is connected to the last node. The address of last node is null. So let's try to understand what I am trying to say. So suppose there is a linked list, first node, second node, and third node. I have a linked list of 3 nodes. So suppose the value of first node is 1, the value of second node is, so suppose the value of first node is A, the value of second node is B, and the value of third node is C, and the address of first node is capital A, the address of first node is X, the address of second node is Y, and the address of third node is Z. So what will happen is, first there will be a head node. So head node will have just a link which will be pointing to the first node, and the address stored in the head node would be X, the address of the first node. Now the X, that is the address of this node, would contain the address of the second node, which is Y, and the value of second node is B, and the link of the second node would contain the address of the third node, which is C, and it would contain the address Y. And what Y will contain? Y will contain null, because it's pointing to null. It is not having any further links. Now this was clear. Now let's talk about some basic operations of linked list. So what are some of the basic operations of linked list? Some of the basic operations of single linked list are insertion an element in the linked list, deletion an element in the linked list. I forgot to mention one thing, that inserting and deleting from a linked list takes constant time. Suppose if I want to insert the first element in an array, so I will simply remove that element, and after that what I have to do is, like, I have to move all the elements one step further. Like suppose I deleted first element, and second element will move to first, third element will move to second position, and likewise all the elements have to move one step further. So in this case we have to traverse whole array. If I have to insert an element at the end, then I have to traverse through whole array, and then I have to insert that element. So insertion and deletion, the worst case of insertion and deletion in case of array is O of n. So in this case only we prefer using linked list. So what we are doing is, when we have to remove any element in a linked list, like I have talked about in my previous examples, the nodes were A, B and C. So suppose I have to delete the node B from the linked list. So what I can do is, I will simply point the address, and that is at the A to C, and B and the next of B would be null. So B would automatically be removed. Suppose this is A, B, C. A is pointing to B, B is pointing to C. So I would simply point A to C and B to nothing, like B to null. So B would automatically be removed. In that way I can delete the element in constant time. Like I am simply picking out the element and connecting it to the next node. So it is taking constant time, because connecting one node to the another node takes constant time, and that's why the deleting also is taking constant time. Now suppose I have to insert an element D in between of B and C. Suppose so I want the order to be like A, B, D, C. So what I can do is, I will move the pointer from B. Previously the pointer of B was pointing to C. Now I will move the pointer of B to D, and the pointer of D to C, and likewise I can see that now A, B, D, C, it's there. Now let's talk about I have given you a basic overview of the situations. Now let's talk about some of the insertion problems. So in what all places we can insert an element in the linked list? We can insert an element at the start of the linked list, we can insert an element at the end of the linked list, we can insert an element at nth position of the linked list. Like suppose we can insert anywhere in between of the linked list. And fourth one is, we have to insert the element in sorted order in linked list. So let's talk about all these problems. if you have to insert an element in the head of the linked list at the start of the linked list, so what we have to do is first we have to create a new node with the value passed to the function as an argument. Now we will have the next pointer of the new node which will point to the head of the linked list or null in case when list is empty. If the list is empty, then the next pointer would point to simply to null, or else it would point to the head, because head is pointing to the first element, so it would point to the head. Now the newly created linked list, the newly connected node, newly created node would now be the head of the linked list. So what is the term complexity it is taking? It is taking constant space. So what we are doing is we are basically taking a node and connecting it to the head. Now this node has become the head, because previously the head was the first node. Now I have showed the address of head to this node, so this node is now the head of the whole linked list. So this is taking constant time. Now let's talk about our second problem, inserting any node in the end of the linked list. Now what we have to do what is the approach that we will be following to insert any node at the end of the linked list? First we will create a new node, and then the value of the new node is stored inside it and store null value to its next pointer, because we have to insert at the end of the linked list, and we already know that the address which the end node of the linked list stores is null. So we first we have to do is like the address that it will store would be null. And now if the list is empty, then new node will simply be the head of the linked list, and if the list is not empty, then we have to traverse till the end of the linked list. Finally the new node will be added to the end of the linked list. So what will be the time complexity of this? The time complexity will be big of n, but we have to remember one thing: this operation is inefficient. At each time we want to insert an element, we have to traverse to the end of the linked list. Therefore complexity of creation of the linked list becomes big of n square. So how to make it efficient? So to make it efficient, we have to keep track of the last element by keeping a tail pointer. Therefore it is required to insert element at the end of the linked list, then we will keep track of the tail difference also. Now let's talk about our another problem, that is traversing through linked list. I have talked about like we have to insert at the end of the linked list, we have to traverse whole linked list. To mention, I am here talking only about single linked list, not about doubly linked list or septuple linked list or doubly circular linked list. So as I have already mentioned that to insert in the end element, I have to traverse the whole element. So what I will do is I will create a new node, and then I will like move one by one until the next of temp is not equal to null. Like, suppose I created a temporary node, and I will like do like temp.next, and I will check temp.next until temp.next is not equal to null, and if the next of this temporary node is equal to null, then I will know that I have reached the end of the element. And suppose if I have given any number, like I have to traverse 3 times, so I will have a counter over there, and I will move it 3 times, and if I will increment the counter every time the loop runs, and if the counter already reached 3, then I'll like just break that loop and move further. Now let's talk about creation of linked list and printing of linked list. So how we will like the sorted linked list. So how we can create a sorted linked list? So a new empty node of linked list is created and initialized by sorting an argument value into its value. Next the node will point to null. If the list is empty, or if the value stored in the first node is greater than the new created value node, then the new created node will be added to the start of the list, and head need to be modified. In all other cases, we iterate through the list to find the proper position where the node can be inserted to keep the list sorted. Finally the node will be added to list. So what I am trying to say is, suppose we have given a sorted linked list, and I have to insert an element in that sorted linked list. So what we can do is, if the element which I have to insert in this linked list is less than the head, or suppose the head is greater than this element, then I will simply add this element in the first, and I have already discussed how we can add the element in the first. And suppose if this number is less than or anywhere between the head and the tail, or at the last, so in any other cases we need to traverse the element, and we have to check whether at which position this element fits, and I have already discussed how we can traverse the linked list. So in that way we can add any node in the sorted linked list. Now let's talk about our another problem. We have to search an element in a linked list. So how we can search an element in the linked list? I have already talked about searching and sorting algorithms, so we could simply use those algorithms here. So searching an element given a head pointer and value returns 1 if value is found and 0 otherwise. So this is our problem. So what how we can do is, first we will create a loop and iterate through the entire linked list, as I have discussed how we will iterate through the linked list, and then we will compare the value of each node with that node, and if the value is equal to the node which we have to search, then we have found the answer, and if we are not able to find, then we would simply return 0 as mentioned in the question. So what will the time complexity? The time complexity would be big O of n, as we are traversing one single time. And what is n? N is the length of the linked list. Now let's talk about our another problem. So what another problem says is, we have to delete the first element in the linked list. So deleting the first element is pretty simple. What is happening is, let's remember the structure of the linked list: head, then first node, then second node, then third node. So what we could do is, we would simply point the pointer of the head element to next dot next, that is, we will simply point the address of the head of the second element to the head instead of first element. Previously the address of first element was stored in head. Now we will store the address of second element of the head, and the address which first element was storing of this. Like previously we know that the first element was storing the address of the second element. Now the first element will store the address null. So in this way the first element is deleted, and now the head is pointing to the second element, and likewise the whole linked list is going. Now let's talk about our one more problem. So let me add on one more thing, that doing this deletion operation takes constant time, that is big O of n. Now let's talk about one more problem. So what this problem says is, we have to delete node from the linked list as given its value. Suppose we have given that we have to delete third node, or we have to delete fourth node. So what we can do? There are two cases. First, when the node that needs to be deleted is first node, and second case, when the node that needs to be deleted is not the first node in the list. When the node that needs to be deleted is first node, so I have already discussed that how we can delete that node. And if that node is not the first node, and if that node is in the middle of or at the end of the loop, in any other cases we will traverse the linked list using a while loop and try to find which node need to be deleted. If the node is found, we will point its previous node next point to the node next to the node we want to remove. So what I am trying to say here is, like suppose there are three elements in the linked list, and I have to delete this element. So this element is pointing to this element, and this element is pointing to this element. So what I would do is, I will point this element to this element and this element to null. So now this element has nothing connected to it, and these two elements are connected. So simply this element would be deleted. And what is the worst case time complexity of this? The worst case time complexity is big O of n. Why big O of n? Suppose these are three elements in the linked list. So if I am deleting third element, so we would simply point this element next to null, and now this element would be deleted in the worst case. So the time complexity will be 3. So this is big O of n, which is equal to the size of the linked operations, and all these problems which I had discussed today in this video was clear. And in the next video I will talk about another linked list also. I am not taking a lot of problems. If you would say, or if I wish, I could take a lot of problems, but here I am mainly focusing on covering more and more topics. Like I want to see that if I can explain those topics or not. It isn't necessary for me that I have to explain it the best way possible, because like I am speaking in English, and English is not my primary language. English is my second language, and I have to improve my English also. That's why I am doing the practice of speaking in English and recording videos in English. I am only recording videos because there are two main things which I have to see. First one is I have to improve my communication skills and my skill of talking to the camera. See, talking to the camera is really very difficult. It needs a lot of confidence, and the way you speak, the way you move your hand, the way you frame your sentences, and the way you frame your words. It's very difficult. And explaining anything on camera and explaining the thing which you are already studying, like I am not a master in data structures and algorithm, but I am still trying to explain and give some value to anyone who would be watching the video. And if no one is watching the video, still I am trying to explain, and I am practicing the things which I need to learn. So I hope this will help me, and in future I could provide a greater value, and I would create good video and good content for the viewers and for the community which I am trying to help. So thank you everyone. That's all for today's video. Bye bye.